discuss some of this on the exam next Wednesday. You'll see it on the handout when you get the handout tonight. Here we go. Sine, cosine, look at those brief definitions. Now, there's 4 more. There's 6. Head on to Stanford. There's still 6. Columbia, there's 6. Berkeley, there's 6. And the trig functions, we're doing right here at SMC. The first one, look at that brief definition. Sine is y, cosine is x. Now, you said, Professor, you said there's 6 of these. This will be the first 2. Number 3, we'll pick another one. It's spelled this way. It's tangent, not tangent line. This is definition trig, a tangent. Abbreviated TAN of theta. Definition, brief. It's y over x. That's its definition. Number 4, I'm going to pick up next this one, spelled this way, secant, abbreviated SEC of theta, but secant of theta. Definition, 1 over x. Number 5, there's 1, it's spelled this way, cosecant, abbreviated CSC theta. Definition, 1 over y. Briefest definitions ever. One more, 6 of these. Last one is cotangent. And I'll get out of your way, guys, so all of us can see this. Cotangent, abbreviated, I'm going to use this abbreviation, COT. Definition, x over y. I could not ever, nor have I ever seen briefer, if that's a word, more brief definitions in my life. Usually a definition takes a little space, you gotta write it out in words. This is my definition. Look at those brief definitions. Now, all I'm going to do tonight to sort of set you up for all this. On the side here, we're going to try a few of these. And look at my definitions here. I hope I can base it on this. That's why I did not erase this right here. Guys, for an example, I'd like to find, let's go back to sine. I'd like to find the sine of 5 pi over 4. Well, sine's definition says find y. But first you got to find 5 pi over 4. And I think we found 5 pi over 4 somewhere if I didn't erase it. Guys, I think it was right here, wasn't it? Someone remind me. Was that 5 pi over 4?
Yes.
Is that true, guys?
Yes.
When I did my work earlier? And the y coordinate was what? Negative radical 2 over 2. That's all they want. You're done. If I ask Mr. Park to do this with the device over there, same answer. Number 2, let's try this one. Let's find cosine. Let's find cosine with this brief definition. Let's find cosine of pi. Just pi. Where is pi? Pi's right here. In fact, I labeled it over here. This is pi. And if I ask for the cosine, I'm looking for the x. What was the x coordinate over there? Negative 1. That's all they want. Now, am I going to argue with these definitions? No way. Tangent? Let's find tangent. Hold on, I got to be careful here. Okay, tangent of, find a nice group. Yeah, 5 pi over 6. Remind you what the tangent definition was. It's y over x. Now 5 pi over 6, if I didn't erase it, let me try to find it, for goodness sakes, where is it? Was it this one, guys? I did so much work tonight, I think it's this one. These are the coordinates. I think, I hope so. Now if I place the y over the x, which is the definition for tangent, I'm placing 1/2 over, what was that? Negative? Radical 3 over 2. Now, of course, I got to clean that up. 2's will cancel, fast way, and you got -1 over radical 3. Now, students asked me at the break, yes, in math, we do not want a radical in the denominator. They call it rationalizing, make it a rational number. So guys, what would -1 over radical 3 look like after I rationalize this, or get rid of it? -√3 over 3. Is that true? And that's the exact value for tan of 5 pi over 6. Mr. Park, do me a favor. Find tan of 5 pi over 6 using your device over there, maybe a calculator, and see what the calculator shows for tan of 5 pi over 6.
That's -1 over √3.
Negative how much?
-1 over √3.
Same thing we got here. Oh, it did not give the decimal approximation.
It gave -0.5774.
0.577?
4.
4.
With a negative sign.
With a negative out here.
Yeah.
That's the decimal approximation. Now, is that the same as radical 3 divided by 3? Sure, it's the same thing, right?
Yeah, I'll do it. Yeah.
Same thing. Okay, we got that. Now we're looking at this. Okay, number 4. Pick up next secant. Let's find secant of, we'll try pi over 2. And since that's new, let me remind you what secant was by definition. Secant is 1 over x. And guys, if I go back to pi over 2, which I think was over here. So guys, was this pi over 2 here, 90 degrees? There's my ordered pair. So it says, please place, what is that, 1 over x? And my x in this case is 0. So I'm looking at 1 over 0, which alerts me to what? Undefined. No answer. And can someone tell me, what do you think? We're not there yet. This is chapter 6, I'm thinking about now. Just this happened. What do you think when they finally say graph secant? And we'll see what the graph of secant looks like. And I'm graphing, what do you think is going to happen on that graph at pi over 2? That's going to be an asymptote. It's undefined. That's going to be a vertical asymptote on the graph in chapter 6 when we finally get there when they ask us to graph these. Next one, 5. Cosecant. Let me try one here. Yeah, let's try. You know what? I hope I labeled off these. So maybe not. Okay, we're going to try it. 7 pi over 4. And the definition is 1 over y. Now guys, 7 pi over 4, in the haste that we had before the break, is 7 pi over 4, someone remind me, was it corresponding with this one?
Yes.
I think it was, wasn't it 7 pi over 4? So this is the ordered pair I'm looking for 7 pi over 4. In fact, it's also on that handout. If we want now, and I'm asking for cosecant 1 over y, well the y is that. So it's 1 over negative radical 2 over 2. In this clever class, can anyone tell me what I'll get if I clean that up?
-2 over that.
Say it again.
2 over 2.
Nope,
Negative
I better do it.
radical 2.
I heard someone else say something. That's not 2 radical 2, I heard 2 radical 2. Negative 2.
Radical 2.
Oh, just negative radical 2? Hang on. So you're saying maybe it's just that?
No, it's negative.
Oh.
Over
Oh, boy. Let me do it.
Oh, yeah.
Would you guys agree, is it one being divided by this? Does this and this say the same thing? They're saying the same thing. And I know in math, that means 1 times, flip that over, I have that. We're doing reciprocal. Is that true? So at this point, I have this. I do a little bit of math to it. And again, I cannot leave that radical 2 where it is. I've got to rationalize, but multiplied by what? Radical 2. Look at this. Numerator, denominator. So you have negative 2, radical 2. And the bottom part there is radical 4, which is merely 2. Where the 2's cancel. What are you left with? Negative radical 2. That's the exact answer for cosecant 7 pi over 4. The last one, I'm running out of space here, number 6. Let's try cotangent. And let me try one here, guys, if it might work for me. Let's see if it will. Let's try cotangent of 3 pi over 2. And cotangent is x over y. 3 pi over 2 is all that we've done tonight. My goodness, I've been busy, you've been busy. It's this one. Is it? Okay, and I'm looking for cotangent x over y. What should I be doing here for x over y? 0 over a negative 1? And therefore the answer is 0. Is that true? You can't go wrong. Now, here's where you could go wrong. You see what I'm doing? I'm just matching things up with my sketch here and the definitions. Where could I go wrong? Alex, if you were asked to find this, hang on, we'll create one for you. Sine's definition is y, but I'm going to give you this angle to work with. I'm thinking of a nice one here. And, sine of pi over 12. And you get desperate. And you look at your unit circle. I don't think there's a pi over 12 on that unit circle. Is there? I don't think there's a pi over 6, pi over 4, pi over 3. You find those easily on that unit circle. I don't see a pi over 12. Is there a pi over 12? No. It might even make it easier to say, Professor, you got me on this one, but to make it easier on me, does anyone know what pi over 12, if you convert it back to middle school, use this conversion factor, I erased it. Does anyone know what pi over 12 converted is? Do it. 15. 15 degrees. If that would help. Now, have I discussed 15 degrees tonight? No. Does it exist? Yes. You go off to Stanford, they say find the sine of 15 degrees. You say, wait, SMC didn't show me, they showed me 30 and showed me 45. And he says when I meet next time, he's going to show me the last one, 60. And those are the basic ones from SMC. And all of a sudden you sit down and Stanford says find the sine of 15 degrees. You say, whoa. I didn't see that SMC. And Mr. Park could easily put it in on a calculator. You guys could put it on a calculator. The calculator will give you an answer. If they say find the sine of 15 degrees, no calculator, you're sitting there thinking, whoa, am I ready for Stanford? Now, at this point, I don't think anyone, maybe, who knows, maybe a student might, if with their experience before they got to me, they may know how to find the sine of 15 degrees. Does anyone know?
Sine of 45 minus sine of 30.
Oh, tell me again now.
Sine of 45 minus sine of 30.
Whoa, you're getting close. I'm not gonna do this now. I'm way in chapter 6 now. I didn't wanna go there. Ignacio, but you made me go. He says, Professor, could I rewrite it? Now, he's being clever. Could I write like that? Is that 15 degrees? 45 subtract 30? He said, wait now, you did discuss 45 tonight, Professor. And you did discuss 30 tonight, Professor. So might I use 45 subtract 30 some way to find the sine of 15 degrees? That is 15 degrees, I think, isn't it? 45 subtract 30? Ignacio, don't go there right now. Now, if you do that, it's going to take a formula to apply this, but he's got a good start. That is 15 degrees. Represent as 45 subtract 30. By the way, another way to represent 45, Ignacio, is this. 15 degrees, 20 subtract 5. Why not use 20 subtract 5?
We don't know those.
Did I discuss 20 tonight? Did I do this business here on 20 degrees? No. 5? Definitely not. Do they exist? They do exist, but we're not responsible for them. So he shows the things we are working with here, 45 and 30. Then in chapter 6, I'll have to go further with you and show you how to do this without the calculator. Guys, these are the ones we're concerned right now. These are the basic ones to work with. Those are my 6 basic trig functions to work with. Any concerns here? Now, this is a good stopping place for me. You got the 6 definitions. Now, we're not ready for the quiz. We got the 6 definitions. Good stopping place for me. Shane, I've depended upon you. I'm going to, I don't know, I hope it's on the handout. I thought I would close down with going back, before we start this little short quiz tonight, going back and looking at another solving an equation, and I'm thinking about the handout that we had. Hang on, guys, let me see if I'm ready for it. Okay, here we go. Yes. You'll see this on the handout. I thought it'd be appropriate to just close down with this. You guys, I'll pick up the trig on Monday with you guys and finish this up. Here we go. Find, solve this with your help. And it looks like this. And I'm really concerned about that exam next Wednesday. Now, can someone give me some input? How would you attempt to solve for X? Alex?
Then you be over X.
Absolutely. And like I said before on the exam, I will do this for you. All right, let U be something so you know it's one of those types. Alex, what are you going to let U be?
E over X.
E raised to the X. Right here. If that's true, I know and you know that first term could be written as this if I wish. That's still e to the 2x. And therefore, he says replace that part there with a u. That becomes u squared, which we wanted. Subtract u, subtract 12 is equal to 0. The reason I thought about this to close down, I cannot believe how math is. You're sitting there as a student, you're into grad school, higher math, and you're thinking, oh no, I don't know whether I'm going to be able to do this or not. And don't you think every professor on this campus has not had those thoughts in some class in grad school, where you just look at it and you say, am I going to do this? I don't think I can do this. It looks crazy. Then all of a sudden, this looks crazy and it takes you down to what? Something simple. But to get from here to here is the problem. But we did it. This will factor, I think. Or that u subtract 4, and what is it? U plus 3. Split this up. You're considering for the u values, those. Now though, what was you representing? E to the x, so now this says e to the x is equal to 4. Oh, I love this problem. E to the x is equal to a negative 3. Guys are asking to solve for x. We're almost done. We've got to find x. Now, does anyone have a clever way to tell me what x must be if you have e to the x is equal to 4? Alex, hang on to it just 1 second. I walk up to you and I say, Alexander, e to the x equals 4. Alexander, quickly tell me what x is. It's that quick. No algebra involved. No solving, no moving something. Does anyone think they know just by merely observing this what x must be?
ln of
Or
4.
maybe another way to express it. No, say, go for it.
ln of 4 equals 6.
X is equal to ln 4. These two are saying the same thing. They're saying the same thing. No middle school, no algebra. This one says, no, so help me out. X is equal to ln
Of
negative 3.
which is that of the domain.
Now, why must I reject that one? Did we say the domain on any log, which was represented as an x, must be greater than 0?
Yep.
So this one out, rejected, cannot have a negative inside there. The only answer is x equals ln of 4. And another reason I brought this in tonight, that's the answer. I would give you full credit. All of a sudden, I think this may have been in your textbook. You check in the back, check your answer, and they have the answer written like this. And all of a sudden you become disturbed about this. You say, Professor, I thought I knew what I was doing and I missed it. How'd you miss it? My answer is ln of 4. I checked the back of the book, they have that.
Because 4 is 2 squared.
Well, what did they do a little bit further than what you did? What could you do up here to show, yes, you could get that? Could I rewrite this as ln of 2 squared? Is that true? 4. And then use the power property we discussed. Move that 2 out front. Would that take me right there? I use power property. 2 ln of 2. True? And therefore you have that answer written in that form. Wow, wow, wow. Guys, I got 5 minutes. You know me, I love my time. I need more of it for this class. You're going to pick up, this tonight, as you need. The solution, I mean not just the answers. This is me, it's handwritten, so